Bismillahirrahmanirrahim. In the second series of lectures, object-oriented programming, today the topic we are going to discuss is encapsulation and information hiding. In the first introductory lecture of this series, lecture 1.0, we have shown this list of topics to be covered in this series. Some of the topics have been covered, others are to be covered. Many of the topics are closely related to each other. For example, we have done a lecture on classes and objects, and we have done a lecture on inheritance. The next 1, 2, 3, they are closely related to each other, even the 4 and 5. But instead of covering them all together and to avoid the confusion, we do it slowly and topic wise. So today we are going to talk about this topic here, encapsulation and information hiding. In many of the books, in many of the material available online, there is a confusion or there is a confusing similarities between these two topics. Both are believed to be same, but we'll make it clear that how they are different and what is the similar elements of these two topics. This is the diagram, two diagrams taken from the previous slides. The procedural programming languages and approaches, we have the design of the program is something like this, where we have the global data, one special method main from which the execution starts, and all the other program elements or program units are methods. So in fact, these are all methods and one global data. And we talked about this in our previous lectures, that the ownership of the global data is not with any of these. They all have the equal access. They can all read, write, or change the data from here. And this is in procedural programming languages. In contrast, in object-oriented programming languages, what we did, we divide the data into many smaller portions, and we put the data into these bubbles called objects, and we put the respective methods into these respective bubbles. So these bubbles are objects. Every object has its own data and the functions. No object can access the other object data directly. So the data is owned by an object, and the data is maintained by the object. The functions are to access the data or to provide access to the data. So this is the big difference between the procedural programming languages and object-oriented programming languages. If we compare the two, what we have achieved here, we have actually encapsulated the concerned data and the functions to operate on the respective data into one bubble, and we name it an object. So what we actually have done here, we have encapsulated the data and the respective functions into an object boundary. Similarly here, the respective data and the concerned operations are encapsulated or put into this object. So this is the concept of encapsulation. Encapsulation says that we have encapsulated the respective data and the functions into an object premises or in boundary of the object. So this is encapsulation. Encapsulation, the respective data and the methods. So rather than having global data, we have many smaller parts of data, but every smaller part of data is actually maintained by the object. So this is the concept of encapsulation. Now moving forward. So what is information hiding? Information hiding, we have worked with these access modifiers previously, that there are four access modifier: public, private, protected. We have seen this protected in the inheritance. Public, when we write public, we write private, or we write protected, but we never write the empty. Any data or method member without an access modifier is a default modifier, and that is the package. What it means when we say is public means this is publicly accessible within the package, wherever this class is going to be placed, or outside the package equally. Private is to the class itself. This X does not exist, or nobody can access X member outside the class. So private is to the class itself. Public is public everywhere. Protected is public within an inheritance chart, within the inheritance hierarchy from parent to child. So protected is public but in the inheritance. One is public, this is general public, generally available everywhere. This protected is public within the inheritance chart, within the inheritance hierarchy, and the default is to the package itself. So the private object-oriented programming convention is that we must make the data private, and we access the data through the methods. So in this diagram, all the data was public. That's why everyone accesses it. All the data is public. Whereas here, the data should not be public. The data should be private. This is the convention in object-oriented programming. In every object, the local data, the instance level data should be private, and it should be accessed through the functions, through the methods. So this should be private, and the method should allow access to the data. So for example, in this class, the X member is private. So this method should allow access to the X member. So information hiding is through these access modifiers. We restrict the information to the class itself, to the package, to the inheritance hierarchy, and this is to allow it everywhere. So for example, we take an example of a canvas, a drawing program. In the drawing program, for example, Microsoft Paint, we have a canvas. On the left side, we have a panel of components, of shapes to draw. Let's run the program MS Paint. So here we have this canvas, and in here we have different shapes. So we select a shape and then draw the shape here. So this is the canvas area, and this is the shape in a drawing program. So we make a class shape. The shape has a name. So in the drawing program, when we move our cursor on top of the shape, there may be a tooltip saying that this is a circle, an ellipse, a box, a rectangle, a line. So the name of the shape, private, then some sort of data which can help us to determine the size of the shape, or the starting point of the shape, or some information about the shape. So that is also private. So we can make some public methods to access these members. For example, set name, get name. We can On one canvas we can make more than one shapes. In Microsoft Paint we can't, but in other drawing program, if we draw more than one shapes of the same kind, we may label the shape differently, or we may name the shape differently for clarity, for identification. So we can make different methods, get and set methods, to access the name, and some method draw, to draw the shape. So in this example here, what we have encapsulated, we have encapsulated the data members of the shape and the methods or the functions required to operate on the data of the shape into the same block called class shape, from which we can create an object. We have covered the class and object topic in our previous lecture. And then we, in the next lecture, we covered the inheritance, and now we talk about encapsulation and information hiding. So here we have encapsulated the data and the methods related to the shape into a shape class, and we have made some of the members private, and we hide it. So here we are talking about the private data members. Next, in our lecture, we may talk about the private method members. So today's topic is encapsulation and information hiding. We stop it here. Those who haven't subscribed, please subscribe to this channel to get the timely notification of the lectures. Until next time, take care. Thank you.